Introduction to Pandas for Market Research. Learn how Pandas helps analyze real market research datasets. Understand customer survey and behavioral data for better decisions. Produce insights that inform product, marketing, and service strategy. These practical steps let you gain value from raw survey results. Running the cell now. We import Pandas, our main market research data analysis tool. We import NumPy for calculations and array support. We import OpenML to access real-world market research datasets. We import warnings to control warning messages. We turn off unnecessary warnings to keep outputs clear. Running the cell now. Understanding market research data and common pitfalls. Market research data includes surveys, campaigns, and customer behaviors. Columns may represent responses, demographics, and feedback. Each row is a survey response, purchase event, or customer record. Beginners may misinterpret missing values or mishandle categories. Always check data types and understand what each field means. Running the cell now. We load a genuine customer satisfaction survey from OpenML. We extract the data into a Pandas data frame for analysis. Let us check the size of our customer satisfaction dataset. Here are the first 3 records to preview the kind of responses we have. Running the cell now. This output shows the dataset loaded from a market research source, with 7,043 customer records and 20 columns representing demographics, service usage, and billing details. Notice how key fields like gender, senior citizen, and churn are categorical, which is important for proper analysis and avoiding misinterpretation of categories or missing values. This snapshot sets the stage for exploring customer behavior and potential pitfalls like overlooking mixed data types or the meaning behind each column. What do you notice about the variety of columns in the output? Beginner example 1, counting churned customers. Business often wants to know how many customers are leaving. We will count how many customers have churned based on survey data. Running the cell now. Here we count customers who have churned versus those who have stayed. Let us print the result to see how retention looks. Running the cell now. This output shows the count of customers who have churned versus those who have not, with 1,869 leaving and 5,174 staying. Notice how the NOS and ES labels correspond to the churn column values, helping us quickly see the scale of customer retention and loss. This count is foundational for understanding customer behavior and guiding business decisions on reducing churn. Try changing a churn to different column names to practice counting categories. Beginner example 2, average tenure of customers. Tenure tells how long customers stay with the company. Finding the average can help spot trends in loyalty. Running the cell now. We calculate the average number of months customers stay. We print the overall tenure value for a quick business insight. Running the cell now. This output shows the average tenure of customers is 32.4 months, meaning most customers stay with the company for about 2.7 years. By calculating this average, the code helps us understand overall customer loyalty and can guide strategies to improve retention. Notice how the mean summarizes all individual tenures into one key number for easy insight. Beginner example 3, frequency of each contract type. See how many customers are on month-to-month, 1-year, or 2-year contracts. This helps spot popular contract types in the survey. Running the cell now. Let us count the number of customers per contract type. We print out which contract option is most common. Running the cell now. This output shows the number of customers for each contract type in the dataset, with month-to-month contracts being the most common. Notice the descending order of counts, which helps us quickly identify which contract types are most and least popular among customers. This aligns with the lesson's goal of understanding contract frequency to analyze customer preferences. Now we load a real-world marketing campaign dataset. The data is loaded into a new Pandas data frame. We rename columns to understandable business field names. Let us check how many records and fields are in this marketing data. Let us have an initial preview of the first 3 rows. Running the cell now. The output shows the dataset has 45,211 rows and 17 columns, giving a sizable sample to analyze contract types. Notice the key columns like per job, marital, and education that describe customer profiles, which will be useful alongside contract data in later steps. This confirms the data is loaded correctly for exploring how many customers have month-to-month, 1-year, or 2-year contracts as planned. Intermediate example 1, customer response rate. Knowing the overall campaign response rate is a key marketing metric. We will calculate the percent of customers who responded a yes. Running the cell now. First, we calculate the total number of campaign records. We count how many customers said a yes to the campaign. We compute the percentage for our response rate metric. We print the results so teams can see how engaging the campaign was. Running the cell now. The output shows a response rate of 0%, indicating that none of the customers in this dataset responded a yes to the campaign. This is important because it highlights that, so far, the campaign has not generated any positive engagement, and you may need to re-evaluate the approach or data quality. The code effectively calculates this key marketing metric by counting yes responses over the total customers. Intermediate example 2, average balance by marital status. Segmenting by marital status can reveal spending behavior patterns. We will break down average account balance for each status group. Running the cell now. We group customer accounts by marital status. We print out the average balance for single, married, and divorced customers. Running the cell now. This output shows the average account balance segmented by marital status, revealing that married customers have the highest average balance, followed by singles, then divorced individuals. Notice how grouping by this marital column aligns with our goal to identify spending behavior patterns across these distinct groups. This insight helps tailor marketing strategies by understanding financial status differences linked to marital categories. Intermediate example 3, how many customers have loans? Loan information helps assess customer credit risk for new campaigns. We will count customers who have at least one loan. Running the cell now. We filter records to just those who have loans. We print out the number of customers who have taken a loan. Running the cell now. This output shows that 7,244 customers in the dataset have at least one loan, as identified by filtering the loan column for yes. This count is crucial for understanding the size of the loan holding segment, which helps tailor marketing strategies and assess credit risk in the next steps. The code's intent is to quantify this segment clearly for further analysis. Now we load a real online retail transactions dataset for behavior analysis. We load 1 year of e-commerce transactions into a Pandas data frame. We ensure that purchase dates are interpreted as real date times. Let us print the shape to understand how many rows and columns we have. And we preview the first 3 online purchase events. Running the cell now. This output shows the initial look at our retail dataset, with over 540,000 rows and 8 columns like invoice, quantity, customer ID, and invoice date. Noticing the shape helps us understand the data scale, and the preview confirms customer IDs are present, which is essential for counting how many customers have loans later in the lesson. This step sets up the data for analyzing customer behavior and linking loan information to customer records. Advanced example 1, highest revenue products. Companies want to know which products drive the most revenue. We will aggregate total sales by product and sort the top sellers. Running the cell now. First, we compute revenue per transaction for each line item. We then sum all product level sales, sort by revenue, and extract the top 5. We print these key products so business teams can focus marketing efforts. Running the cell now. This output shows the top 5 products driving the highest total revenue, aggregated by summing sales of each item. Notice that .com postage leads significantly, highlighting its major contribution to overall revenue. This confirms the code's intent to identify and prioritize the best-selling products for business insights. Advanced Example 2, Cohort Analysis of Customer Retention. Cohort analysis tracks customer groups over time. We will simulate simple monthly user activity to spot retention trends. Running the cell now. We fix the seed for reproducibility. We generate a range of 24 sequential monthly periods. We simulate a data frame with customer IDs, cohort start dates, and active user counts. We print the first 3 rows so you can see the cohort and activity pattern. Running the cell now. This output shows the first 3 rows of our simulated cohort dataset, where each row represents a group of customers who signed up in a specific month along with their active user count. Notice the key columns, sign-up_month tracks the cohort timing, and the active_users reflects engagement for that month. This setup is essential for analyzing retention trends over time by comparing activity across different sign-up cohorts. We import matplotlib to visualize our retention trends. We plot cohort activity for each month. We add a business-friendly chart title. We label the x-axis with sign-up dates. We label the y-axis, showing how many users are still active. We rotate X labels for easier reading. We ensure the layout fits. Finally, we display the chart so you can interpret retention behavior visually. Running the cell now. This line plot shows how the number of active users varies by sign-up month, helping us visualize retention trends for each cohort. Notice any peaks or declines that indicate whether users from specific sign-up month stayed active or dropped off over time. This helps us understand customer engagement patterns and the effectiveness of retention strategies. What might a sudden drop in active users indicate? Error handling, spotting missing survey responses. Missing values can bias results if you do not check for them. Always count missing data before analysis. Running the cell now. We print how many missing values appear in each column of the survey dataset. Running the cell now. The output shows that there are 0 missing values across all survey columns, indicating a complete dataset. This confirms that no data cleaning is needed for missing responses before proceeding with analysis, which is the key intent of this error handling step. Always verifying missing counts helps ensure reliable and unbiased results. Ask yourself, which fields might matter most for customer decision predictions? Error handling, incorrect grouping in market analysis. A common mistake is grouping on the wrong field and misreading results. Always triple-check your Group B before making business recommendations. Running the cell now. Here we group by a partner to show what happens if you accidentally analyze the wrong demographic. We print results that may mislead marketing strategies if misapplied. Running the cell now. Here, grouping by a partner yields average monthly charges for just 2 categories, yes and no, which oversimplifies the customer data. Notice this narrow grouping masks important variations across other factors like contract type or customer segment. This illustrates the lessons point to carefully verify your Group B fields to avoid misleading conclusions in market analysis. Always verify with business partners that your groups match campaign targets. Error handling, misreading NPS and Likert scale data. NPS and Likert scores must be interpreted using clear business rules. 0 is not always the worst and 10 is not always the best. Definitions matter. Running the cell now. We simulate a Net Promoter Score survey for error handling practice. Customer IDs show individual responses. Ages add context for analysis. Region allows for geographic insights. Each NPS score is randomly generated from 0 to 10. We preview the first 3 results. Running the cell now. This output shows the first 3 rows of a synthetic NPS dataset with customer demographics and scores ranging from 0 to 10. Notice that the NPS score includes 0, which may or may not represent a negative sentiment depending on business rules, highlighting the importance of correctly interpreting these scale values. This preview sets the stage for understanding why careful error handling is crucial when analyzing NPS data. We categorize each customer as a promoter, detractor, or passive based on NPS rules. Promoters are loyal enthusiasts, detractors are unhappy, and passives are neutral. We print the count by segment to inform improvement priorities. Running the cell now. This output shows the distribution of survey respondents classified by their NPS scores into promoters, passives, and detractors according to standard business rules. Notice that the largest group is detractors, scores 0 to 6, highlighting potential customer dissatisfaction, while promoters, scores 9 to 10, are fewer. This classification is crucial for correctly interpreting NPS data, emphasizing that the score thresholds, not the absolute values, define customer sentiment. Best practices: customer segmentation using Pandas. Divide your customers into useful groups by age, region, or spending. Segmentation helps find target audiences for campaigns. Running the cell now. We segment the NPS survey by age group, young, middle, and senior customers. We show the average NPS per group to identify which segment is happiest. Running the cell now. This output shows the average NPS score for each age-based customer segment created using PD Cut. Notice how customers are divided into young, middle, and senior groups, revealing that seniors have the highest average score, which can guide targeted marketing efforts. This demonstrates how segmentation by age helps uncover valuable patterns in customer satisfaction. Best practices: cross-tabulation in survey results. Cross-tabulation lets you compare 2 categorical variables, such as region and NPS type. This reveals important relationships for marketing teams. Running the cell now. We create a cross-tabulation table of customer region by NPS segment. We print the table to quickly spot regional strengths and weaknesses. Running the cell now. This cross-tabulation reveals how NPS types vary across regions by showing counts for detractors, passives, and promoters side by side. Notice that the North region has the highest number of passives and detractors, which could indicate areas for improvement. This helps marketing teams identify which regions need targeted strategies based on customer sentiment categories. Best practices: score construction for survey analytics. Index scores help make survey data meaningful for business reports. Let us create a satisfaction index as a new metric. Running the cell now. We compute a 100 scale satisfaction index for easy comparison. We show the new index for the first few customers. Running the cell now. This output shows the first 3 rows of the dataset with a newly created satisfaction_index column, which scales the original NPS score to a 100 range for better interpretability. Notice how each satisfaction index value is exactly 10 times the NPS score, reflecting the linear transformation applied. This step is crucial for converting raw survey scores into a standardized index that is easier to communicate in business reports. This is a powerful step for executive dashboards. Subscribe to our YouTube channel for more real-world business analytics walkthroughs. Best practices: trend analysis on market data. Spotting customer trends over time is vital for business direction. Track how campaign responses change each month. Running the cell now. We group marketing campaign responses by month. We print the monthly breakdown of yes and no responses. Running the cell now. This output shows the monthly counts of different campaign responses, with months as rows and response categories as columns. Notice how response 1 generally has higher counts than response 2, indicating more positive or engaged customer actions. This table helps track how customer responses vary by month, which is key for spotting trends and adjusting marketing strategies over time. End-to-end market research, from survey to insight. We will take customer satisfaction survey data and summarize the main driver of churn. The analysis will lead to a practical business recommendation. Running the cell now. We analyze the percentage of churn for each contract type. The printout shows which contract types have the highest loss rate. Running the cell now. This table shows the percentage of customers who churned versus those who stayed, broken down by contract type. Notice the clear trend: customers on month-to-month contracts have the highest churn rate, at about 43%, while those with longer contracts churn much less. This insight pinpoints contract length as a key factor in customer retention, guiding our later recommendation to encourage longer commitments. What recommendation would you give based on these churn patterns? Learn more strategies by exploring our next Pandas for Market Research video series.